All right. So yesterday, again, circumcenter. All right. The circumcenter are the three perpendicular bisectors. The three perpendicular bisectors do not have to go through the vertices. That is called the circumcenter. The circumcenter is equidistant from the vertices. That is the important concept. All right, that is the important concept you need to remember. Circumcenter, equidistant from the vertices. Three perpendicular bisectors. The three perpendicular bisectors do not have to travel through the vertex or through the vertices of the triangle. The end center are the three angle bisectors. And the angle bisectors, the points on the angle bisector are equidistant from the sides. So that's how it was easy for me to remember all of this. Points on the angle bisector are equidistant from the sides. So the end center is equidistant from the sides of the triangle. The three angle bisectors meet at the end center. And these points are called points of concurrency. All right, points of concurrency is just a fancy way of saying where all the three lines intersect. All right. So with that little bit of information, all right, what we will do now is we'll just review 7, 8, 9, 10 for a quick second. If L is the circumcenter, then BN is equal to what? BN is equal to NT. Very good. I also could ask about GB. What is congruent to GB? What is congruent to GB? Yes, there you go. That's how they confuse you. And then if I said HK, HK is congruent to what? Exactly. And then if I said LB, LB is congruent to what? And what? And LK. All three of these things, all right, are congruent. All right. Is everybody happy with that explanation? That's all there is to it. That's what you have to remember. All right. And then the other thing is, if there is a right triangle involved, I need everybody to make sure you remember this. If there is a right triangle involved, the famous theorem, a squared plus b squared equals c squared, can apply. All right. If you're missing a side, all right, a squared plus b squared equals c squared can apply. Anybody have any issues with that? All right. Please, it would be beneficial if you take yourself some notes and write it a few times. All right. That way, it's not a difficult thing. All right. I would also expect if you forget, you can easily reproduce that information by understanding what a perpendicular bisector means and what an angle bisector means. All right. Down here, now we already reviewed the end center. The end center are the three angle bisectors. And if you are on the angle bisector, that means you are equidistant from the sides. You are equidistant from the sides. Notice this figure right here, and this has been on the test and people make mistakes. This right here is the end center. Is AL, AG, and AY equal? Definitely not. Definitely not. If that was the what? Circumcenter, she would be correct. All right. This point is equidistant to the sides. And we said yesterday, equidistant to the sides means that it is the distance from a point to a line or point to a segment is the perpendicular line segment. So supposedly, all right, and obviously this is not a very good drawing. Now I'm trying to demonstrate to you here that if you were to draw this, please listen to what I'm saying. Does everybody agree? This right here is not an extension of this segment right here. Does everybody understand what I'm saying? All right, that's not the extension. All right, those are different segments, definitely different segments. All right. So now, if this angle, if this angle is 21 degrees, then what is this angle?
21.
And of course, if this angle down here is 32, then the other angle is also what? Now, do we agree all those angles are being cut in half? So the angles of a triangle add up to what? That means the three angle bisectors cut the 180 into what? 90. So that means this angle, and this angle have to add up to what? That's just a shortcut. You don't have to do that, of course. You can just say 64 plus 42, subtract from 180, but that's just a little shortcut there. All right, anybody have any questions with that? All right. So that's the information. All right, that's the information. All right, let's go down. All right, we kind of talked about this. All right, let's look up here. Circumcenter. All right, so BR is congruent to what? AR. Come on, everybody. Come on, this is where you're making the difference in your grade. All right, participate. If you don't know, now speak up. BR is congruent again to what? AR. CS is congruent to. Now, BP is congruent to. Wait a minute. P, this, I don't know. They can't get it in here close enough, right? That's the P. All right, which is the circumcenter. So then PB is equal to what? PA and PC. Anybody have an issue with that?
I understand that, but what if like it would be congruent to like PS, like just the circle?
That's exactly right. It's equidistant from the vertices. All right, equidistant from the vertices. All right, all of these are important for you to see it. That's what I'm trying to tell you. Once you see it, honestly, that's why I can say it's easy, because I can see it. If you're sitting there going, I don't know what he's saying, it'd be helpful. All right, just let me know and I can try to draw it for you and show you. All right, it's visual, a lot of it. All right, what?
There's also an S and an R and a T. Is that for the end center?
No. The reason I'm saying no so quickly is because these are the perpendicular bisectors, has nothing to do with that. All right.
What's the point of having them there?
Because they were constructed to find P. You see what I'm saying? You have to construct the perpendicular bisector, and it's not even a very good picture. All right. You understand what I'm saying? All right. So now the end center. All right. Because we know the end center, what's true about this angle and this angle? They are congruent. Thank you. What is the measure of this angle right here? 40. All right. Now, what is AK and AU? 20. Anybody have any problems with that?
Wait, yes. AK and AU are lines.
What's the length?
Oh.
All right, now if I ask you to find this, if I ask you to find this angle here, we have to solve for X. Do you agree? I don't feel like doing that. All right, but we'd solve for X, plug it in, we get the angle, correct? And then those three angles add up to what? 180. These two angles, subtract 180 gives you this, and then divide by 2 gives you the other. So I agree with that. All right, I don't care about that. That's too easy. All right, anybody else? Anybody else looking over these worksheets? You have a thorough understanding of now circumcenter and end center. Thank you, sir.
For 12, it says find the measure of angle QPK.
Q, P,
Yeah.
Just do.
yeah. I think it's, I think what they meant was QPA, right? Do you agree with that? That's why these books, I don't really trust them. That's why I like to write my own. All right, everybody's good with that? Easy enough. Anybody?
Okay, so can you explain how you got for that figure, how you got 20 for 8 and
Yeah, it doesn't look like 20, right? But because it's the end center, remember, that's where you understand the definition. The end center means that the distance is the same from the sides of the triangle. So let me highlight something. From here to here is how much? So that has to be what? You with me? All right, now if you forgot, it's supposed to be able to draw a circle here and draw it inside, but you see how bad their picture is, right? Really bad picture. All right, that's supposed to be able to be something like that. All right, where that's the radius. Obviously, that's not the right drawing. Good now? All right. So again, that's why it's important to know this meaning. All right. Because the pictures could be drawn bad. All right. And just like you don't want to be fooled, like over here. All right. This right here, PA, these three things are not equal because it's not the what? Circumcenter. All right. Hopefully everybody agrees with that. All right. Now, the next one is also on your iPad because I think there's some graphing I wanted you to look at. So download 5.2 for me. And again, this is just more information, just more information. Bless you, bless you. Yeah, these are the ones that kids do not like.
do not like
Yeah, you don't like it. Because I've been doing it for a long time.
Mr. Strong.
Yeah.
For E, U, and A, and D, U, B.
What are you talking
For angle.
about? I don't know what you're talking about. Are we on 5.2?
I'm looking at the triangle.
No, don't worry about the triangle right now. I just need to explain a few things first. All right, we have so far we've done the circumcenter and the end center. All right, the next one is the centroid. And then after the centroid comes the orthocenter. All right, so medians. All right, and everybody understand the median. All right, the median and the centroid. All right, the centroid is the point of concurrency if you draw the three medians in. If you draw the three medians in, you get a point of concurrency. So now, again, let me just draw the triangle and let's describe exactly what a median is. All right, so here we go. All right, I think generally it's better just to pay attention. All right, and then it's really simple. All right, then you can figure it out. But what I'm going to do is I'm just going to draw a triangle. Hopefully. All right. Then what I'm going to do is I'm going to label it ABC. Now, the medians, it's easy for me to remember median because it's in the middle. All right, and middle was a midpoint for me. All right, so the perpendicular bisector went through the midpoint. All right. But it was also a line that was perpendicular. So what I'm going to do now is I'm going to draw, or I'm going to put a midpoint in here. So I'm going to look at BC and I'm going to say, okay, BC right there. No, that's not very good. All right. So if I'm trying to find the middle, all right, what I want to do is say maybe like that. Hopefully you agree that kind of looks like the middle. All right. Now, if that's the middle, all right, notice if I draw this line right here, this would be the perpendicular bisector. Do we agree? But if I extend this, does it go through the vertex? No. So now watch. This now is called a median. All right. The reason why it's called a median is because it's not necessarily perpendicular to the opposite side. Is everybody with me on that? So that's a median because that line goes through the midpoint of BC. So everybody agree with that? That's called a median. All right. Now what I'm going to do is I'm going to draw a median to another side. All right. So I'm going to put my dot at vertex C. I'm going to come over here and I'm going to try to put it somewhere where it looks like the middle to me. All right. So that looks like the middle. So now those 2 points intersect, right? Or those 2 lines intersect at what's called the centroid. All right. That is called the centroid. Now, obviously it's a point of concurrency because that is what we are working on. All right. So now I'm going to move this letter B out of the way. All right. And now, does everybody agree? I only need 2, right? Because I automatically know it goes through the middle of that. All right. So what I'm going to do now is I'm going to draw the other line. And depending upon how accurate I am, if you notice, if I come down here, then that looks kind of like it was cut in half. Does everybody agree with that? Right. So if I call this ABC, let's just call this X, Y, Z, and then we'll just call this P. All right. So the reason it's called the centroid, all right, in some geometry books, they call it like the center of mass. All right. In other words, I could cut that triangle out and I could balance it on P. All right. If I wanted to cut that out, I could put it on the tip and the triangle would perfectly balance. All right. So I don't know how to prove that part. All right. But I do know that those 3 lines intersect at point P and it's called the centroid. Now, what's interesting about the centroid is it divides those medians. Those are called medians. The median is divided into always this ratio. This we call X. PC is called 2X. And then XC would be called what? 3X. That's exactly right. Now, there's no relationship between XC, PZ, and AY. They're not equal. They're not in some ratio. There's nothing really fancy about it, except that those lines are cut into that ratio, X and 2X. So over here, if I want to label this, I shouldn't have labeled those X, but it's all right. So this over here, if I called this Y, this over here would be what? 2Y. And if I called this Z, this would be what? 2Z. Now, people always ask me, how do I know which one's small and which one's larger? Well, to me, it's obvious, right? From the centroid or from point P to the side is always the smallest unit. All right, from the vertex to the centroid, that's always the largest. Everybody with me on that? All right. Now, again, I'm trying to relay this information to you. All right. I don't care what you write down. Right. I'm just saying some of you guys have to try something different. All right. It's not just absorb information. All right. Now you got to make yourself notes because to me, again, this all seemed logical to me because I could look at it and say, wow, that looks kind of correct. Like if I was taking a test and I didn't know, I used to measure from here to here on a piece of paper. And I used to measure from here to here. And then I used to measure from here to here and go, wow, that's 2 times bigger. Right. So there's always little things you can do to help remember these things. But if you forget, all right, there's also things you can do to try to help yourself get into position to get the right answer. All right. Does anybody have any questions with that? That's the ratio. All right. For the centroid. All right. Now let's go back and see what they want to talk about. All right. So now Ava was trying to tell me something. Hopefully it's not messed up, but here we go. AU is 16. So let's not answer these questions. All right, let's just answer what's on the figure. So if somebody says, oh, and by the way, by looking at that, how do I know that that's the centroid? Can anybody tell me? Yeah, all of them. That's exactly what I want to hear. Because EC and AE are equal, CD and DB are equal, AF and FB are equal. That makes it what? That makes it the centroid, right? Notice it's not, doesn't say it's perpendicular here, perpendicular here, perpendicular here. If those were all perpendicular, it would be the perpendicular bisector. These are the little bits of information that I'm trying to help you with. So when you sit down and take the test, it's not just, there's so much information. All right. That's how I'm trying to show you. That's how you tell the difference between everything. You have to be observant. You have to look at the figure. You have to make judgments. Is everybody understanding why that's a median and not a circumcenter? Right? The median must go through the vertex. The circumcenter does not have to go through the vertex. These are not right angle marks down there. So I know it's not the circumcenter. All right. So now that you understand that, all right, I'm just going by what's off of this. If I say, I think AU is 16, then what's UD? 8. Thank you for that information. And if BU is 12, then EU is what? 6. All right. Now it says that CF is 18. So now remember what I said, X and 2X. So the whole length is what? No, the whole length is, no, listen to what I'm saying. If UF is X and CU is 2X, then CF would be 3X. Thank you for whoever said that. So the whole length is what? 3X. So if they give you the whole length, you just automatically divide by what? You automatically divide by 3. That's how easy. So what was the whole length again? 18, right? So now CF or 18 equals 3X. So then X is equal to what? So that means UF is what? And CU would be, that's how simple. All right, that's all there is to it. All right, very basic. But of course, you have to remember all these properties. That's what makes it hard. You have to remember the properties. And come on now, you just got to put a little bit of effort into it. All right, if you're having trouble, that means you're not writing down enough information. You're just relying on your brain to remember everything. And there's an overload of information that's going on. You're not expected to remember everything. That's why you're supposed to practice. All right. Now, we could say, for example, if EU is 6 and UB is 12, that means that EB is what? 18, guys. I don't have to tell you that. Right? You have the 2 parts. You can find the 3rd part. All right. If they give you 1 part, then you can figure out the other 2 missing parts. All right. That's all they're trying to say there. All right, so here we go. Let's look down at the next one. See how simple this is. If UK is 12, then CU is, wait a minute.
24.
Now that's what I'm saying. It's easy to make a little mistake. Is that the short distance or the long distance? This is the short. We're looking for the what?
Oh,
We're looking for the long. So the long would be 24 and the whole thing would be 36. Now, if UD is 9, JU would be what? 4.5. And then, of course, the whole thing would be 13.5. Thank you. All right. Now, of course, they better give us EM, right? Because we can't just figure out what EM was out without knowing at least one of the three parts. So EM is what? So MU would be, and then UE would be, I'm telling you guys, it's really that simple. It's all there is to it. Simple, simple, simple. All right. And of course, every year I say that, and then you take a test and it's all this information, and then you just don't put it all together. All right. So now let's look down. All right. Now, here's what I was referencing. The ortho center you can put down if you want. There's nothing really special. All right. Ortho is a fancy way for saying perpendicular. All right. And ortho center are the three altitudes. The ortho center is the three altitudes. All right. Now I've looked up information on ortho center trying to find out what makes it so special. And it doesn't really make it anything so special. It's just that it's the three altitudes. All right. So what in the world does that mean? So let's go back to my figure here. All right. Now notice what I'm going to draw here. From each vertex, I'm going to draw straight down. So it's what? Perpendicular. There you go. All right. Now I don't like my drawing because it almost looks like a right triangle. So I'm going to put it in this way a little bit.
even though it's not.
All right. So if I draw it perpendicular, now someone said something kind of important. Does it have to go in the middle? Actually, no, it doesn't. All right, it doesn't have to go in the middle. All right, so that to me looked like a perpendicular. Is it a perpendicular bisector? No, it's not. It's just perpendicular. All right. So now I'm going to draw the other perpendicular from here. I'm going to come over here. I'm going to try to find exactly perpendicular. Not so good. That looks a little better. All right, that looks perpendicular to me. And then, of course, if I'm doing a good job, I can go through that point right there. And all three of these lines are perpendicular.
Wait, how come they're not perpendicular?
Did it bisect the opposite side?
Oh, no.
There you go. That's why I say the meaning of the words is important. Perpendicular and bisect. Perpendicular means it's 90 degrees. Bisect means it cuts the side in half. This fits the definition of perpendicular, but does it fit the definition of bisect? No, it does not. So this guy right here, believe it or not, is called the orthocenter. That is the orthocenter. All right. And again, like I said, I wish I could tell you something valuable about that, but I cannot. It does divide the triangle into three equal parts, but there's no reason for me to draw all that out for you. All right. That's just called the orthocenter. All right. Now, believe it or not, if we took this triangle, all right, and we calculated the orthocenter, the end center, the circumcenter, and the orthocenter, if we did all four of those fancy terms, believe it or not, all four of those points would create a line. All right. All four of those. If I did the orthocenter, the end center, the circumcenter, and the centroid all at once on the same triangle, all four of those points would line up and make a line. All right. And that is called Euler's line. All right. He is the famous mathematician who calculated and figured all of that out. All right. Again, I'm not going to make you do that because, first of all, in order to find the angle bisectors, we have to have some constructions. All right. So again, it's not really possible for us to demonstrate that, but there is a theorem that shows that all 4 points are always on the same line. I'm not saying they are the same point. I'm saying they would line up in the same point or on the same line. So again, that is called the orthocenter. And notice we have a blank page for the orthocenter. There's nothing to calculate except, right, we're trying to find the orthocenter. And this is what I was saying at the beginning of class. What time's the bell ring today? All right. So I think what I'm going to do is this. I think I don't really have enough time to show you how to calculate the orthocenter and the centroid. Well, I might as well get, let's see. Oh, that stuff is really easy. How much time do we have? Today's a short day. Do we still get out at 41?
Yeah, I think today's, it's Wednesday,
Oh, no, I was thinking it's advisory.
you know.
All right, it is advisory, but it's not a short day. Okay, so let's do this. Let me just do. All right, you guys can just, I know there's not enough time today, so we'll do this. 17 through 40, knock all that out. And then tomorrow I'll show you how to construct or find the orthocenter and the centroid. All right, so everybody get busy on that, finish up. You probably finished a little bit early. That's okay. Tomorrow we'll do that because we don't have enough time to do all that. All right, and remember, guys, what I'm saying for some of you guys, I want you to do better. Some of you guys who are not doing as well as you would like to. So get busy, practice, review the notes tonight. All right. If you understand the circumcenter and the incenter, now you have another 2, orthocenter, and you have the centroid. There's a lot going on. All right. Practice. All right. If you get done early, look over your notes from yesterday. All right.